So again, another episode. We're gonna explain vortex ring state and what it is and how you can avoid it. So my airline window and my Microsoft Flight Simulator here. So vortex ring state. Vortex ring state is a state where the helicopter will fall, will get swallowed by its own airflow. So if you look at my AirlandFS window, I have here my mouse, you'll see this is the induced velocity of the helicopter, this VI number of the main rotor. So this is basically the airflow, the wind that the helicopter creates when you hover. Uh, and this induced velocity will change a lot during your flight because you'll get into some fresh air, and so you'll don't fly in your airflow anymore. Vortex state happens when, due to certain flight condition, you fly into your own air, so the air that your rotor is pulling down. So imagine your rotor is creating a huge wind downwards, okay? And so as much collective as you put on, you'll be flying into the wind. And I will try to simulate vortex state here. It's not an easy condition to get into. I know it's been discussed a lot on flight sim forums and such, but you really need to have some unfortunate conditions. And usually, I mean, first of all, you have to have very low speed, and secondarily, because otherwise you'll just fly out of the vortex, and secondarily, you have to have a certain descent speed. This is why if you're in a hover, like I'm here, and I'm looking at my velocities on the top line to keep my helicopter almost at zero, if I start this, let me just climb a little bit more. The more you climb, the less ground reference you have, and it's going to be more difficult to understand if, see, in this case, I'm actually flying backwards, so I will not enter a vortex ring state. If I didn't have my airline values there, I wouldn't be able to see that. Okay, let me just go a little bit down. Okay, now I'm almost at zero. Okay, now what happens if I start reducing my collective and going down at about 500 feet per second, less than 500 feet per second, uh, I will uh, I will have a safe descent. Okay, now it's safer even because I'm kind of going forward. But if, let's say I'm hovering and I want to descend and I do something stupid because I'm late, I'm just doing, I'm lowering my collective a little bit more. What you'll see is that my airspeed, okay, you see it starts uh, descending a lot, very much quicker. And this is actually a vortex state. I have my message in the other uh, monitor, and it just said vortex state. So it's not easy to get into that, but it's also easy to get into that. And you can have vortex swing states even if you think you're hovering over the spot, or let's say you're just advancing very slowly, but you have some backward wind. So your air velocity is actually zero, and you'll enter a vortex swing state again. So now let me show you the two ways you can get out of a vortex swing state if you're into one. Uh, as you say, I mean, you have to have a certain velocity. So it's in AirlandFS, it's calculated as a velocity. I think it's below 10 knots or something like that. So you really have to be uh, almost not moving. Okay. And to exit the vortex ring state, there is two ways. One is to move outside of your vortex, like pitching your nose down. So let me try and enter a vortex ring state here. I'm just gonna go lower my collective. Okay, here I'm in vortex ring state. I'll just put my cycling up and okay, but I've gained some speed and I'm now out of the vortex ring state. The other maneuver is called the Vuchar maneuver, and actually it's a slightly better way. Uh, it's been developed by a French-Swiss helicopter pilot called Vuchar, and it's a slightly quicker way to get out of vortex state. Let me explain you why. So instead of moving your cyclic forward, you move your cyclic sideways, okay? And why is it faster? Well, if you look at your helicopter, this is a long, it's an elongated body, like a cylinder in a way. well, you have the rotor on top, but it's a cylinder. So moving a cylinder, there is this the weight distribution along the cylinder uh, is different. If you think about the cylinder, I'm now imagine I'm flying my cylinder and I'm doing that. Okay, so I have a certain inertia moment, moment of inertia to do that. When I do that, it's faster, okay, because there is less mass to move, and this so the inertia moment of inertia on your longitudinal axis is lower. So let me just again try to find my zero speed position, even on the right hand side. I'm looking at my numbers there. I'm here. Now I'm entering the vortex swing state in a second. Okay, I'm flying backwards here. I have to look at my velocities. It's very hard to tell your velocities when you're so high. So I'm looking at my first line velocity in order to have a velocity which is below 10 in any direction. Okay. So I'm going down and entering my vortex instant. That I'm doing it down on purpose. Okay. Okay. No, I'm not entering because I'm flying. Okay. I should enter here. Not yet. Not yet. Not yet. Not yet. I'm not. Okay, I didn't see the message, so I might not have been there. Let me do it again. One sec. Okay, it's I was looking where I'm flying. Okay, there is no wind. I just set this airport with no wind. Okay, let me just zero everything. I'm flying backwards. Okay, I'm at zero here. Let me just go forward. So I'm at zero here and almost zero. Good. Let me just put my collective down. A little bit exaggerated. Okay, I'm in vortex ring state here. I'm falling from the ground, and I'll just do that. Okay, and now I'm out of my vortex, and as you see, mm, uh, my descent speed uh, slows a lot. All right, that was about it for vortex ring state. Hope you enjoyed it. Thank you, and bye bye.